trying to keep my balance. It's like everything. Actually, it's everything in chemistry. If you can't balance equations, pretty much furpalooed. It's balance equations. I need my mind in chemistry in order to balance this. I need my guts filled with this. Balancing equations is exactly what it sounds. There is a law called the law of conservation of mass. It means, so I have this practice up here. Hydrogen reacts with oxygen to produce water. I didn't do the states, so don't bother complaining. In this equation, according to the law of conservation of mass, the mass of these products have to equal the mass of the reactants when it's in a closed environment. See, like gases can escape and masses can always change, but assuming ideal conditions, there shouldn't be a change of the mass, ever. And so this equation needs to be balanced. We need to make sure that we have the same amount of hydrogen and oxygen on the left-hand side of the arrow as the right-hand side of the arrow. And so to visualize this balance, I have drawn this crappy balance, which you can see is out of balance when I draw this. So check this out. First step to balancing is I like to draw a border right here. And I'm going to draw right down to this balance. So I'm going to draw and itinerize, or whatever that is. I like to write down on each side the inventory. So we have hydrogen over here and we have oxygen over here. We also, I like to make the exact same inventory over on the right-hand side in the same order, because when we're comparing how many hydrogens and oxygens we have on the left, they have to match the right. So let's match the right. So over here, you can see that I have 2 hydrogens on the left. So that's 2. 2 oxygens. Why am I doing that? 2 oxygens on the left. Over on the right, we have 2 hydrogens, but only 1 oxygen. And so when you're drawing this, you would have an out of balance. Balance. Voila. It's out of balance. You see, we have 2 hydrogens and 2 oxygens on this side, 1 oxygen and 2 hydrogens on that side. So in order to balance this, you have to always look which side of your inventory has less mass. So I can see that the hydrogens are totally balanced. We've got 2 on this side, 2 on that side. That's great. Now the thing is, you have to use what are called coefficients. Coefficients are these numbers that we will put in front of these molecules that multiply them. So you're allowed to do this. You see, when we're not just talking about 2 hydrogens and 2 oxygens. You go ahead and ask Avogadro all you want. He'll tell you exactly how many particles are in a mole of this substance. Okay, there's tons, billions of trillions to the power of 23 or whatever it is, right, of molecules. We're just trying to tell the reader in this equation how many of each compound you need so that we satisfy the law of conservation of mass. And that's what balancing is all about. And we use coefficients through multiplication. So in order to get oxygens balanced, I need to multiply the side. So I'm going to go over this side. I need to balance this. I need to multiply this molecule. I need to multiply this oxygen by what number so that it equals 2 on that side. Well, easy. That's 2. So we put a giant 2 right there. Now when you put, and here's the good rule, when you put a coefficient in front of a compound, always adjust the inventory, the complete inventory. I've put a 2 in there, which means we now have 2 waters, 2 moles of it, 2 molecules, whatever you want to say, okay? And so that means 2 times 1 oxygen is, and this is how I adjust the inventory, 2. However, I now have 2 times 2 hydrogens, 4. Which means now my hydrogens are out of balance. And that happens. So let me just go over to this side for a second. And wait a minute. Ha ha! Out of balance. You see what happened? Our scale tipped to the product side. It went to the right. The mass is not conserved because now we have 4 hydrogens and 2 oxygens. And over here, 2 oxygens and 2 hydrogens. So we look to over here. This hydrogen has the least amount on the reactant side, and I need to multiply this 2 by something to get to 4. So 2 times 2, put a giant 2 up here. This is now my coefficient. 2 times 2 hydrogens is 4, and holy crap, now we can see in our inventory, and wait a second, ta-da! Totally balanced. Now, this has made what is called a molar ratio, which means in order to make water by combining hydrogen and oxygen, we will need exactly, and I'm going to put this proportion, 2 moles of hydrogen to 1 mole of hydrogen will produce 2 moles of oxygen. And all of our mass is balanced. Now, we do this so often in chemistry, so often that it's like it will become a force of habit. A habit that you really need to be awesome at. Let's go over a complicated example now. So what we have in this equation is we have a hydrogen sulfate. If it was in an aqueous solution, but I didn't do states again, don't complain. That would be sulfuric acid reacting with this base, aluminum hydroxide. So this is a neutralization. Don't worry about that if you don't understand it. We're just balancing equations. These 2 compounds react together to produce aluminum sulfate and water. We have ourselves, of course, step 1 would be to make my little border. Now, in order to balance this, okay, you don't necessarily have to write down the inventory of the reactants and the products. I do this in my head now, but I've done 1.5 billion of these, like yesterday, to make it a little bit easier for me. I know what to do. I would suggest if this is your first time, write down the inventory. What do you got to lose, right? Just keep track of things in your head better by writing it down. Didn't some philosophizer say that? Here is a hint, something that is difficult. Remember in these brackets, that's hydroxide and there's sulfate. Those are both polyatomic ions. You're supposed to treat them as 1. So when you write down the inventory, write them down as 1 essence. So my inventory, hydrogen, sulfate, aluminum, and hydroxide. Write down the same inventory on the product side. Hydrogen, in the same order, so that we can better keep track of what's going on. Now, in order to balance equations, we first have to take an inventory of what we have. Let's just do this quick, huh? Where the crap is the hydroxide? Here is a trick number 2. When you have hydroxide on this side and nothing over there, you can rewrite water like this. I'm going to rewrite this equation. It's still going to be H2O, but I'm just going to rewrite it like this. HOH. It's a great trick. Now what this means is we actually have I know I broke a chemistry rule just now, I'm sorry, by writing the 1. How many hydrogens do we have now? 1 of them. How many sulfates? Still 3. How many aluminums? 2. How many hydroxides? 1. Now, let's balance this thing. And you can start in any order you want. I know which one I should start on because I've got the practice and I can see what's happening here. But you know what? Let's just start at the top. So be it. Hydrogen. There's 2 over here, there's 1 over there. So I'm going to go over to this side and I'm going to balance it. What times 1 equals 2? Put a giant 2 in front of there. Now we have, and adjust all the inventory. 2 hydrogens, 2 hydroxides. Jolly good, balanced. On this one, sulfate, we got 1 sulfate on the left, 3 sulfates on the right. We're gonna go over here. What number times 1 sulfate will equal 3? A giant 3. So 3 times 1 sulfate is 3, but you have to adjust the inventory. That means I now have 4 hydrogens, but I just balanced that. That's not fair. Yep, straight up. Now we gotta change this. Why didn't you tell me that I made a mistake? That's 6. But it doesn't matter. We still have to change it. Now, in this situation, what I would do over here, quite honestly, I'd erase this coefficient and I'd start all over from the beginning, right? I would keep this 3, the coefficient over here, but now it's a little easier because you have to do some weird math, and some of you don't like weird math. 1 times what equals 6? Well, everybody's yelling at me, 6. So I'll put a giant 6 there. Now we got 6 hydrogens and 6 hydroxides. Jolly good. So balanced, let's go over here. We've got 2 aluminums on this side, 1 aluminum on this side, so let's go over to the reactant side. What times 1 equals 2? That's 2. Put a giant 2 coefficient and adjust your inventory. We've got now 2 aluminums, because 2 times the 1 aluminum is 2, and we have 6 hydroxides. Holy crap. It looks balanced. 6 and 6, 3 and 3, 2 and 2, 6 and 6. Assuming we did all our math right, we now have a molar ratio for this equation. 3 to 2 to 1 to 6. You're going to need that molar ratio later on in life, but for right now, we just balance this equation. And isn't that a nice thing to do? Balance equations? Just keep practicing. You can do it. You have to if you want to be good at chemistry.